In today's video, we are going to be building a URL shortener, which I think is definitely one of the best portfolio projects you can do as a junior and maybe as an intermediate developer. And the reason for that is, especially with the advent of LLMs such as ChatGPT and Gemini, many people can already write Spring Boot projects that have like hundreds of controllers and services in it. And for an interviewer, it doesn't really show much how many classes in there or how many controllers and APIs you have implemented because that might as well be very basic copy paste from the LLMs. But with the URL shortener, the story is different. You just have one controller, one service, and one entity, but there are a lot of engineering trade offs you have to think of, and you actually have to be able to answer in a technical interview. And in this video, I'm going to be walking you through with every single step of those engineering trade-off decisions so that you don't just memorize, but you also understand the trade-offs between various alternatives as well as understanding how to implement them by using Spring Boot. So without further ado, let's actually jump ahead to the code. And as always, we are going to be starting with a Spring Initializer to get a basic project up and running. For the language of the Spring Boot project and as well as the project build tool, we are going to be using Java and Maven as always. And for the Spring Boot version, I'm going to go with the oldest available version. And I'm going to make up some project metadata. The group name is going to be Spring Diaries. The artifact name is going to be Shortener. And as always, we are going to go with demo project for Spring Boot Diaries. And although I'm not going to be touching the packaging or the Java version, I'm going to be changing the configuration type to properties just for a change because in the last project video, we had to use the YAML files. And right after that, we are obviously going to hop into the dependencies section. Now, first things first, we are going to be needing Spring Web because we are going to be exposing REST APIs. And right after that, we are going to be needing Spring Data JPA as well as the MySQL driver, again, also called the MySQL connector. And last but not least, we are going to be taking in Lombok because I really don't want to write setters and getters and constructors every single time I change a field. And although that might sound entitled, this is actually going to be keeping our project clean and readable as well. And although I said last but not least, I'm also going to add validation dependency so that we can have some Spring validation magic sprinkled in our project. So I'm just going to go ahead and create this project now. And right away, the Spring Initializer is going to give me a zip file in which there is a basic Spring Boot project. And inside this project, we are going to be finding a POM.xml file, which stands for Project Object Model, which is basically the basis of our Spring Boot application, which is also to say that if you open this up with IntelliJ, not the whole project, but just the POM.xml file, the IntelliJ is going to handle the rest for you and open up the whole project instead of just one file. And as you can see here, we already have a basic project structure here in which we have a Spring Boot application annotated main class with a single main method in it. So before anything else, in order to be able to get this application up and running, what we are going to need is that we are going to have to add certain data source properties in our application YAML or application properties file. And the reasoning for that is actually quite simple because if you remember, we had added Spring Data JPA as one of our dependencies when we were initializing this project. And by default, that dependency is looking for a certain data source it can connect to. And we as developers are supposed to be providing Spring Framework with those particular data source properties so that the application can get up and running. So I'm going to go back to the IntelliJ and under the resources folder, I'm going to find the application properties file. And do remember that if you had picked YAML file as the configuration property here, in IntelliJ, you would have found an application YAML file instead of a application properties file. And as always, I'm going to be using the default data source properties that I have on my computer, but this format is for application YAML files, so I'm going to polish this up a little bit by telling Spring Boot that Spring data source.url is going to be this one. And instead of semicolon, I'm going to have to use equal sign, and it would make sense to type dot instead of C, if that makes sense. And right after that, I'm also going to have to copy and paste these two. and finally change these semicolons to equal signs. And right away when I try to rerun my application again, hopefully this time around we are going to get our application up and running. And as you can see here, we have started shortener application log down here. And now that we have a basic Spring Boot application up and running, we can actually start implementing our business rules. So right away, I'm going to go ahead and create a new Java class under the package controller, and I am going to call this class URL controller. And right away, IntelliJ is going to warn me about that I shouldn't be making typos, so I'm going to go ahead and rename this one. And the reason I created controller before everything else is something I would like to mention today, which is called API first design. So in a nutshell, what API first design suggests is that before you write any piece of code, you define your endpoints, the inputs, the outputs, the exception cases, and then you can go on proceed with your coding. And this doesn't necessarily mean that this is the perfect approach for every single project you are going to be working on. But I think in this particular case, this is going to help us a lot because when we have sorted out the inputs and outputs and hence the functionalities that are going to come with them, it is going to be essentially more easier to implement the rest of the application. First things first, we are going to be using the REST controller annotation for this class in order to declare our intentions to the Spring framework that in this particular class, we are going to be exposing REST APIs. And if you go inside this annotation, you can actually see that this is a combination of the controller annotation and a response body annotation. So in a way, what you could have also done is that you could have annotated this class with a controller annotation, and then for every single REST API exposed in this particular controller, you could have annotated that method with a response body annotation as well. But this is just a much more convenient way to implement REST APIs and REST controllers in that sense. So let's actually start with implementing those APIs. First of all, we are going to have a basic Java method that is going to be publicly available, if that makes sense. And the responsibility of this API is going to be taking a long URL form and returning a short form of it. So for starters, we can type something like this is going to be returning a string, which we are going to change eventually. And I'm going to explain why. And I'm going to call this method shorten URL. And again, this API is going to be taking a parameter string long URL, or we can even call this URL. And again, we are going to be changing this one as well. And as you can see here, we already have a basic Java method. What is missing is that this particular Java application is not accessible from the outside web. And that is why we have REST APIs in the first place. That is why we actually imported Spring Web as our dependency in the first place. So I'm going to go ahead and add a annotation on this method, which is a common way of declaring your intention in Spring Boot applications. And the first design choice you are going to have to make, and there is only one correct answer for this one, and that is when you are using request mapping, and we are going to change that as well, but I'm trying to make it as step by step as possible so that you can understand my way of thinking and arriving at certain conclusions. So if I type in request mapping and go inside this annotation, we are going to be looking at an enum that is called request method. And if you have any experience with HTTP requests, you might be familiar with verbs such as get, post, put, patch, and delete. And obviously there are these three ones, but they are not very much widely used. So again, the first design choice you're going to have to make is that which request method, which HTTP verb are you going to be using for a API that is going to be taking a long URL as a parameter or as an input, more technically speaking, and it is going to be returning something, a short form of that URL that can be reused later. So if you're a beginner, you might think that, okay, they are going to get something from us, so we have to use the get mapping. And I'm actually going to go back to our URL controller, and instead of this one, we are going to be again using another meta annotation that is called get mapping, which is a direct equivalent of request mapping with the method request method get. But as you can see here, the first one is much more precise and intentional, so I'm going to be using that one. Or am I? Because the thing is, we are not going to be using get mapping for this particular API. And the reason for that is simple. In order for us to be able to return a short URL that are going to be later referenced, we have to make certain changes in our database. And when you are making changes on your server-side applications, which includes your database application as well, in this case MySQL server, first of all, you forget about get mappings, because even if you are going to be returning stuff, that is not going to be read-only operation. Now, if I come back to the request method, the two main contenders for our API are post mapping and put mapping. We might as well add in the patch as a third alternative, but I'm going to stick with post and put, which you are going to be encountering most of the time. So I'm going to go back to my URL controller and I'm going to annotate this method with post mapping and put mapping, which is not going to work, but this is going to help me visualize an important concept, a concept that you might be asked in an interview, and it is going to be quite impressive if you get to answer this question. And that question is, what is the difference between post and put mapping? And the answer, and obviously the concept you are going to have to be able to explain, is the concept idempotency. And what this in the simplest terms mean is that when your server receives the exact same request more than once, does the output change? So we can summarize it as the ability of an API to produce the exact same results when the exact same input, and I'm going to get this to a new line so that we can see it in one screen, and I'm going to type in when the exact same request is received more than once. And the difference between post mapping and put mapping is that the post mappings are not supposed to be non-idempotent by default or by convention, if that makes more sense, and put mappings are supposed to be idempotent APIs. And what that means is that if I send the exact same request to this API 5 times or 10 times, if this is a put mapping, this is not really supposed to be different than sending this exact request only one time. So the design choice of using a post mapping or a put mapping annotation for this API, it actually boils down to one simple question. If I try to shorten the URL google.com 7 times or 5 times for the sake of brevity, is this going to be any different than receiving it once? And most of the time you are going to be holding a metadata for each creation, and it doesn't have to be a user, it doesn't have to be an IP address. Even if you hold the metadata of creation timestamp, you are going to have to recreate the exact same URL, or more particularly, more precisely, you are going to be have to inserting another row in your database with the exact same long URL, in this case google.com, but the shortcode and the creation timestamp and any other metadata you are going to be holding must be different. So in this case, we don't expect our API to be idempotent, so I'm going to go with post mapping for this particular API. And I'm going to remove these redundant lines, but I'm going to keep the rest as it is so that you can reference them later. And finally, I'm going to remove this unused import and come back to our method. So here we are going to have to make a call to a service layer because we don't want to put everything in one class. That breaks the separation of concerns, that breaks your testability, and that is going to break everything that has anything to do with readability and maintainability in the long run. So I'm going to go ahead and create a service package as well as a service called a basic Java class called URL service under that particular package. And I'm going to open the service and the controller side by side so that we can have a more visual understanding of what we are doing. Now, first things first, just like we annotated this class with a REST controller annotation in order to declare our intentions to the Spring framework, we are going to have to annotate this class with a service annotation. And both of these annotations are actually meta annotations. They are derived by this certain annotation called component, and REST controller is derived by controller annotation and hence the component annotation again, which is going to help the Spring framework handle the dependency injection and maybe inversion of control instead of we having to instantiate and inject every single service repository and controller objects and their instances around the application. So I'm going to close these two annotations, actually this one too. And in the URL service, what we are going to need is that just like this API specifications, we are going to be needing a public method, public so that it can be accessed by the controller class, that is going to be returning a type of string, which is going to be the short form of our URL. And do remember that we are actually going to change all of this, but I'm just deliberately postponing that so that you can see the difference side by side when we have done everything. Just as a spoiler, I can tell you that it will be much easier to understand and internalize the motivation behind DTOs, which stand for data transfer objects. So I'm going to call this method shorten URL as well. And notice how I am naming my Java methods. They are actually business vocabulary. So this is also going to be taking a string URL as a parameter. And again, this is going to be doing stuff and be returning a string. So first things first, what we have to do here, we need to call the service method in our API method. But what we don't want to do here is that we don't want to really create this service manually with calling its constructor and then call this new method called shorten URL using that particular instance, because this is going to be messing up with your application's memory in no time. Every single time you get a shorten URL request, you don't really want to be creating a whole new object. And that is why we need and we love and we respect Spring Framework, because it is going to be handling dependency injection for us. And that is the exact reason why we actually bothered to add this annotation to our URL service class. So what you can do here is that you can actually define a class level variable, and the type of that variable is obviously going to be URL service, and I'm going to name this variable again URL service, but you can name this variable car, and this is just going to work fine as well. But obviously your future self and your colleagues are going to hate you for this. And what you have to do here, you're going to have to create a constructor with this particular URL service parameter. And now instead of creating an instance every single time a client would like to shorten a URL, you can simply reuse this URL service instance in your class. And if you would like to go one step ahead, you can actually remove this one from the picture, and you can use a annotation called requires arguments constructor from the Lombok package. As you can remember, when we were initializing our project, we had added a dependency called Lombok. And as you can see from the description, this is actually going to be helping us reduce boilerplate code. In this case, our boilerplate code is that constructor that I had here. And imagine this controller has more than one dependencies, and you're going to have to rewrite them, and they're going to take space, and they're going to be making the most important pieces of code, which are your APIs in your controller, much less accessible in a sense. So I'm going to go ahead and instead of this one, I'm going to again use the required arguments constructor annotation from the Lombok package. Now, in order to be able to implement this shorten URL service method, we have to think through the process. And for starters, you might be thinking like, okay, first of all, we are going to need a unique code, unique short code. And if you included the uniqueness in your thought process, that is already a good start. But before everything else, you actually need to validate the URL, because as you can see here, in this particular case, we don't have any validation. A client may as well send in their first name and last name, and we are not supposed to be shortening those ones. So the first thing we are going to have to do is that we are going to have to validate URL. And then we are going to be generating a unique shortcode, after which we can process these data to the database and then return meaningful data to the application's client. And even one of the most trivial operations here, which is to validate a URL, you are going to have to conduct and go through a thought process, and you're going to have to make some design choices. So the two choices that we are going to talk about in this video is to where we are going to be placing this validation logic, and secondly, how we are actually going to be implementing that. And for the first question, there are three alternatives that come to my mind right away. First of all, you can validate the URL right here in this shorten URL method. And right away, I can tell you that I don't like this option because, again, there is a concept called separation of concerns. And the concern of this particular method should not be URL validation. It should be shortening process. It will obviously contain some sort of validation call. It is going to call some sort of method of its own class or another class, but it really isn't supposed to be doing the validation itself. And the two options that we are going to be left with is, one of them is to create a private method in this particular class that is going to be returning a Boolean value, valid or not. And the method signature would look something like this. The name is, I think, can be is valid, and you are going to be taking a URL as a parameter, and then you are going to be returning true or false based on your implementation. This is actually good enough. But what's better, in my personal opinion, is that you create a new package called util, which is short for utilities. And under that util package, you can create a new class called URL utils, for example. And the reason we do that is that this particular URL validation logic is not really supposed to be specific for this particular URL service. Now, if you ask 100 different senior engineers, you're going to have different answers because there is no one single truth when it comes to design choices such as this one. So you can leave this method here, you can take it apart into another URL utils class, which is what I'm going to do, which is what I like. But again, which is what I personally like, that is the important point. But you should actually be able to understand the trade-offs between them and need to be able to explain what you did and why you did it. So if you're going to be using it like me, you have to reason your approach in a way that you think this is going to be utilized in different classes. So the logic should be centralized. Or if you were using it in the URL service, you should be reasoning about it in a way that you think this should be, and this is going to be used only and only in this class. So hence it should belong to this particular class as a private method. And I'm going to go ahead and annotate this class with a component annotation as well, so that we can use that here in our URL service without we having to instantiate an instance of it. So I'm going to go ahead, just like we did in the URL controller, I am going to declare my dependency URL utils. And just like on the left-hand side, I'm going to annotate this class with a required arguments constructor annotation. And right away, what we are going to do is that first things first, before literally everything else, we are going to be checking, and I don't really see the method here, so I assume it is private. Yeah, and if this is private, you are not going to be able to use it from an outside class. We are going to be calling this method is valid. Of course, we are going to have to implement that with this URL, and we are going to assign its value to a Boolean variable. And obviously, if the URL is not valid, what we can do is we can actually throw an exception and we don't return anything to the client. And we can implement this by typing runtime exception and specify the message URL is invalid, let's say. Now I'm going to leave the unique shortcode generation to the last because that is the most complex engineering trade-off we are going to have to make. And in order for me to be able to visually explain that, I'm going to have an entity and a repository implemented already. So for this moment, I'm going to type in a placeholder called shorten code, and I'm going to set the value of it as to do, so that both we don't forget to set it, as well as we have a variable that we can use in the next steps. And in order to be able to persist something to the database, we obviously are going to need a database table, and hence, in order to be able to achieve object relational mapping, we are going to need a Spring Boot entity in our application. So I'm going to go ahead and create a new class called URL entity under the package entity as per convention. And right after creating this entity, first things first, obviously we are going to be adding getters and setters, because pretty much every single Java class that you can imagine is going to need these two. And there are a couple of annotations that we need to remember when we are creating entity classes. The first one is that the entity annotation, as simple as that sounds. And what this entity annotation does is that the Spring framework, or more particularly Spring Data JPA, is going to be able to understand that this Java class is not just a basic Java class. This is actually a class that can be mapped to a database table. And speaking of tables, we are also going to have to annotate this class with a table annotation. And we are going to have to, as you can go inside this annotation, you are going to find the property called name. And you are going to have to specify the table name here. In our case, it is going to be URL. And if you don't do this, if you just annotate this with a table annotation or none at all, what's going to happen is that the Spring framework is going to be looking for a URL entity table that is going to be derived by the class name in your Spring Boot application, which is not going to be the case if you are using a relational database and are going to be following the industry standards. So I'm going to take that back. And in this entity class, we are obviously going to have some fields. And at the very least, we need a field. We need a database column where we can hold data of the long URL and one where we can hold the short URL form. So I'm going to go ahead and create these variables. We are going to have a private string main URL. We are going to be having a short code, and we are going to be annotating these fields with a column annotation so that, again, just like we annotated this class with an entity annotation so that Spring Data JPA knows that this URL entity class, although it is a basic Java class, it should be mapped to a database table. We are going to be annotating these fields with column annotations so that the Spring Data JPA knows that these fields are not just basic Java fields, but actually that are going to be mapped to the columns of the table URL. And in every single Java class that is going to be annotated with an entity annotation, you are going to have a field that is going to be annotated with an ID annotation, because otherwise Spring will have no way of managing that entity, or more particularly a reliable way of managing that entity on your behalf. Because in order to be able to do that for you, Spring has to know, and Spring is going to know that in a way that you declare that which field uniquely identifies an entity. So here you might be tempted to call this shortcode an ID because this is going to be unique anyways, and we actually would like to enforce that this is unique because we don't want collisions, we don't want overlaps in our short codes. But in proper relational database design, what you are going to do is that you are going to assign incremental numerical IDs in your database tables so that when you are relating your, let's say, this URL table with other tables in your system, you don't have to refer this particular table or particularly the rows in this table by a string that has like maybe 6 or 7 or 8 characters. Instead, you are going to have a simple integer like 3 or 80 or something million that is easily understandable from a human perspective. And also, it is much more efficient from a computational standpoint because it can be indexed very efficiently. So I'm going to go ahead and remove this one, and I'm going to be introducing a new field variable called private long ID. And now this time around, I'm going to be annotating this field with an ID annotation. And so that we can hold the database application responsible for ID generation, we can use the generated value annotation. And if you go inside it, there are certain generation types that you can use here. And in order to be able to, again, hold the server, hold the database application responsible for it, we are going to be using strategy of identity. And what this strategy basically means that you don't decide IDs, you just send data to your database application, like in this case, a main URL and a shortcode. And when you are persisting to the database is going to be responsible for setting IDs on your behalf. And one question that you might encounter is that, and this is something even I learned just last week when I was recording a video for a video tutorial, a very good question might be what happens if you use generation type auto. And if you are wondering that, and even with the risk of losing you right now, I would definitely suggest you to go ahead and check out my last video in which we built a very basic event management system. And there is a chapter called lesson learned because I learned that the hard way too. And there is an explanation of 6 or 7 minutes that is going to change the way how you look at generation types. At least it's changed the way I look at them. So I'm going to take this back and we are going to be using generation type identity for that particular reason. And last but not least, we are going to be needing a repository layer. So I'm going to go ahead and create a new repository package. And under that package, we are going to have a URL repository interface. And that one is important. You are not going to be using a class for this one. And the reason for that is we are going to be extending a either CRUD repository or more capable than that. We are going to be implementing a JPA repository which itself is an interface. And in order to be able to extend the, in a sense, capabilities of this interface, we are also going to be implementing an interface ourselves as well. And if you go inside this JPA repository, this is implemented with 2 generic types. And here what the T and the ID refers to is that T refers to the class that is annotated with the entity annotation, in our case, URL entity. So I'm going to go ahead and type that in URL entity, comma, And when I go back to the JPA repository, you're going to see a field called ID. And that is the reason why we had to annotate a field with an ID annotation. You are going to be using the type of this variable as a second parameter, as a second generic parameter to your particular repository. So I'm going to go ahead and type in long and come back to our URL service to inject that repository. I'm going to type in private final URL repository, and I'm going to name this URL repository as well. And again, now that we are using Lombok's required arguments constructor, I don't have to reconstruct my all arguments constructor, because think of it this way. If I had an all arguments constructor right now with just the URL utils in it, when I had added private final URL repository as a new dependency, I would have to reconstruct this constructor method either by typing it manually, or I could go constructor, command A, command N. Is this the end of the world? Probably not, but is the Lombok annotation much more convenient? I personally think so. Therefore, I'm going to use it from now on. And right away, what you are going to see is that when I type in URL repository dot, the JPA repository actually provides us with various methods, with various functionalities out of the box. And we can have convenient access to certain delete methods, certain find all methods, or find methods more particularly, which are used for read operations. And we are going to have certain persistence methods that in fact we are going to use in this project. And as you can see here, when you would like to use the save method, you are going to be needing an entity as a parameter, and that entity is going to be the representer of the row that is going to be persisted into the database table. And what I mean by that is that I'm going to add a semicolon here so that I don't forget that later on. For example, if I create a new URL entity, and I'm going to open that on the left so that we can cheat a little bit, and I'm going to create a new URL entity with the no arguments constructor, right away I can pass this URL entity instance as a parameter to the save method that comes from the CRUD repository. And you might be thinking, I don't remember us implementing a CRUD repository. We had seen that, we had decided that we are going to be using JPA repository. But if you go inside this JPA repository, and I unfortunately misclicked there, you are going to be seeing that this JPA repository actually extends the functionalities of list CRUD repository. And if you go one step inside, this list CRUD repository, it actually extends the capabilities of CRUD repository. Therefore, when you are using JPA repositories, by default, by hierarchical reasons, you are going to have to access to every single method and functionality within this CRUD repository as well. So I'm going to go back to the URL service now, and notice that this is just an empty URL entity right now. This is not going to be saving any meaningful data, although we called the save method on this URL repository instance. What we are going to have to do is that, and this is actually our persisted database to-do item. So I'm going to delete that one, and I'm going to be setting URL entities certain properties, namely the main URL and the shortcode. The main URL is going to be the URL that is going to be provided by the client of this API, and the shortcode is the one that we are going to be generating. So first of all, I'm going to be setting a shortcode just to show you what happens under the hood. And when it gets more and more visually understandable, then we are going to add on to these basics. Notice that I'm not going to be setting an ID because we would like to database server to handle that for us. And that is the exact reason why we use generation type identity in the first place, so that we don't have to go like, okay, URL entity.set ID with who knows particular long ID. We can actually skip that. We can actually focus on our basic business data, and that part can be handled by the database server, if that makes sense. And last but not least, we are going to have to returning a shortcode, and that is going to be, okay, I now realize that I mistyped that, and instead of shortcode, I typed this as shortened code. So I'm going to rename that as well. And I'm going to go back to our controller to see if we have anything missing. But first, we are going to go to the properties. And I'm going to explicitly set a Spring JPA Hibernate DDL auto property as create, so that when we are running our Spring Boot application, it can create the missing parts in our database. Because if I go over to my terminal and execute a query such as select asterisk from URL, as you can see here in the demo DB that we are going to be using in this particular project, doesn't actually contain a table named URLs. Instead of writing a table creation query by hand, we are going to have Spring Boot handle that for us. But do remember that this is not something to be used other than prototyping, because at this very moment, I am the only one who have access to this particular project and particular database. If you are interning in a software development company and you are playing out with certain parameters and certain fields in your entities, and you are using create DDL auto, in a database that everyone else also uses, they're going to hate you for it. So just be aware of that. So I'm going to go ahead and rerun this application now. And I'm going to enable annotation processing so that IntelliJ knows that we are going to be using this Lombok annotation as well as the others actual like getter and setter annotations. And now we are seeing that our application has actually started. So if I go ahead to my terminal and execute the exact same query again, instead of a table doesn't exist error, we are going to be seeing an empty set log. So first things first, I'm going to change this to validate so that it doesn't recreate everything every single time we rerun our application. Now I'm going to go ahead back to my URL controller to make the final checks. And there are two things that we need to change before even getting our application running. First of all, we are going to specify a path here, and I will call this, let's say, shorten. And secondly, by convention, when you are dealing with post APIs, by convention, the way you transmit data, the way you communicate business data, not metadata such as the IP address or something like a channel type, but rather an important data for that particular API, let's say URL in this case, you are going to be communicating that data with a request body. So what I'm going to do is that I'm going to have to annotate this method argument with a request body annotation. And I'm going to have to fix this typo. And right away, we are going to be able to get our application up and running. So as you can see here, we have the started shortener application in 2 seconds log. So I'm going to go ahead to Postman to give it a try. So first of all, I'm going to create a new workspace where we can send an HTTP request. And now that we are working with a post mapping annotated API, I'm going to use the post as the HTTP verb. And instead of box that we have used in the last tutorial, we are going to be using the path shorten. And for the body, I'm going to be, okay, I first need to check what this is valid method returns. And it actually returns false. So this is not going to work, but this is good in a sense so that we can see both cases. If I send a raw body, which is not ideal, that is why we are going to switch to DTOs, spoiler alert. And if I try to shorten the URL google.com and send this, this is going to result in an internal server error because as you can see here, the URL is invalid by default. We always return false. So we are going to have to fix that to see the happy path. And during that time, I'm going to go ahead to my terminal and see if there has been any persistence to our database, which is not the case. Now that the URLs are by default valid, I'm going to go back to the Postman and send the exact same request. Again, actually, this time around, I'm going to be sending in facebook.com. And this returned us the value to do, which is the default hard-coded shortcode. And if we go into this terminal, and you might not be able to see this, but I honestly have no idea how to, okay, there is a zoom in button here. Okay, this is still going to be rather small, but as you can see considerably more vividly, this has returned us the to-do message that is our shortened code. And if I go ahead to my terminal and rerun the exact same query again, now that we are seeing that http://facebook.com is now mapped to to-do, which we are obviously going to have to re-implement. But what I want you to first realize is that this is actually quite bad design. Now we are calling an API with the path shorten. Okay, that makes some sense. We are going to be shortening something, but this URL by itself, it doesn't specify anything. It doesn't specify any sort of intention. So what you can do here is that in your application, even if you are taking one input, which is a basic string, you can actually use a DTO class for this. So if I go ahead and create a new class under the package, either model or DTO, that pretty much depends on your taste and your project specifications. This time around, I'm going to go with DTO. And I'm going to call this class shorten URL request DTO. And I suppose I tried to create a package rather than a Java class. So I'm going to go ahead and again try to create a Java class this time around. I'm going to type in DTO.shorten URL request DTO. And yes, this time around, we got the DTO package as well as the shorten URL request DTO class. And again, as always, we are going to be needing getters and setters. And here we are going to have a URL or a main URL as a class field. So what this DTO data transfer object is going to enable us is that it's actually twofold. First of all, in most of your APIs, you're not going to be taking only one input. You are going to be taking several inputs, and you don't really want to take them one by one. What you can do here, you can actually group them under this DTO class and then pass them around in your Java classes, for example, from your controller layer to your service layer, and then maybe even a persistence layer in which you make certain cache related operations, let's say. And secondly, if I now, instead of string, if I take a shorten URL request DTO as a parameter, and in order to be able to get this application running, we are going to have to do minor changes, and we are going to go ahead and fix this too, because now we are breaking the contract between us and the compiler. We are declaring our intention in a way that we say, okay, every single call on this method is going to be with a string parameter, but we are not calling this with a string parameter now. And you might be tempted to say like, okay, I'm going to just go request DTO.getURL, but this defeats the whole purpose of using DTOs. Even if you only have one field in that DTO right now, what you are going to do is that you are going to fix your service layer, adapt your service layer in a way that it receives a DTO. And here we are going to be taking a request DTO. And now that we need the URL more than once, I'm going to assign it to a separate variable using request DTO.getURL. And right away, what this is going to do is that when I go back to my Postman and send the exact same request or Twitter, let's say, this is not going to work out because this is not the way our application wanted data from us. It didn't want a plain string as in this one. It actually wanted, given that we had a URL field in this class, what this API now expects is that if I go back to body and I'm going to pick out JSON so that we have a more beautiful lines that we are going to write, this is going to be taking a JSON object, and the parameters of this JSON object, the content of this JSON object is going to be URL colon, and then we are going to have our URL that is going to be processed. And when I send this now if we go back to our database application, and although this is bad design, but obviously we are not going to leave as it is, we are not going to be using to-dos as shortcodes. Now this time around, what we have done here, we achieved the exact same thing, but this time around, this is much more intentional. The client is able to very precisely specify what they are looking for. And obviously your application, your API is also very well defined. It very well conveys intent in a way that it states what it needs. And we can actually use that exact same logic for responses as well, because now what we are getting is a basic shortcode. And imagine that we are going to be replacing this with certain random strings. This is not going to make any sense. So what you can do here, just like the way we use the DTO for the request body, we can actually use a DTO for the response as well. So I'm going to go ahead and under the DTO package, I'm going to create a new class called shorten URL response DTO. And again, this is going to be needing a getter and a setter annotation, unless you want to be creating those with your IDE. And this class is going to have a private field called shortcode. And now we have to do the same things again. First of all, we are going to have to change the return type of this one. And now the contract is again broken because this shorten URL method of this URL service is returning a string, not a shorten URL response DTO. So we are going to have to fix that too. And here you have a couple of alternatives. One of them is you can create the new response DTO using a no arguments constructor by using the keyword new, and then you can set the shortcode with the shortcode that we are going to be generating, and then we can return that response DTO. Or if you would like to be more concise and ensure brevity, what you can do is you can use a pattern called builder pattern. And if you are not using Lombok, this is going to be quite complex to implement, but Lombok makes this extremely easier. What you can do is you can annotate your class with an annotation builder. What you are going to be able to do is that you are going to be able to call a builder method in your response DTO class. And if you go inside this builder, now we can see it because this is not yet compiled. And feel free to take a moment and look up what builder pattern is. Again, with the risk of losing you, I think this is an important one to know. What this is going to provide you with is the capability of adding certain fields, or more particularly setting certain fields by using their names. So what I can do is I can say, okay, I would like to build this response DTO with the shortcode. And imagine you have tens of different variables. Instead of writing entity set dot, entity set something, you can actually add them one by one, and all you're going to have to type is the field name only twice. And then at the end of it, when you call the build method of this inner builder class, you are going to be getting a response DTO, which you would like in this case. So I'm going to go ahead and delete these two, and I'm going to end this line and rerun my application. And if I go back to my Postman and execute the exact same request, now this time around, not just our request is much more readable and precise, our response is also much more intentional and declarative in a sense. And that is the reason why I implement this API with plain string objects in the first place, because as I mentioned, I think it is much easier to understand and internalize why the use of DTOs matter that much, because this makes everything much more precise and technically accurate, if you will. So with that, I'm going to go back to the IntelliJ, close these two DTO classes, and apart from the second API that we are going to be implementing, we are actually done with this one. So for a moment, I'm going to close these down as well so that we can focus on the service logic once and for all. Now, if I go line by line, the first thing that pops to my eye is this particular line where we initialize a string with a hard-coded value to do. So first things first, we are going to fix that. What we have to do here is that we are going to be able to generate random alphanumerical values instead of assigning the string value to do for every single URL that we would like to shorten. I'm going to type in generate random string values in Java, and I'm going to go for this. Now here I'm going to look for any now alphanumeric implementations. And okay, this one is not going to be anything remotely alphanumeric. So I'm going to go ahead and jump to 5. Okay, this method looks quite nice, but I'm not sure if I really want to use this. I think there must be something out of the box. And we have a possibility of using this random string utils as it turns out, but that is under Apache Commons lang dependency. And just like when we were initializing our project, we added certain dependencies, even if they were directly tied to the Spring framework itself. We had to do that. I suppose we are going to have to get that too, because if I, let's say, go to the IntelliJ and start typing random string utils, the IDE is not going to be able to find anything. And by that, we are actually going to be able to see live how Spring manages dependency management as well. So I'm going to take this dependency name and I'm going to look for that in the Maven Central. And I'm going to have to fix my internet connection that has gone for some reason. And when I refresh this page, we are going to be landing in a page called mavenrepository.com. And here I'm going to be using the one that has the most usages. And as you can see here, if I scroll down a bit, it is going to providing us with a XML definition that we can take into our POM XML file. If I go back to my IntelliJ and if I find this POM XML file here, you can also do that by double clicking shift in IntelliJ and type in POM XML. Now, do you note that if I scroll down a bit, we have a properties dependencies under which we have several dependency definitions. And in addition to these, it doesn't matter where I put this, I'm going to add this dependency as well. And I'm going to see that IntelliJ is already proposing us to sync our Maven changes, which basically means that we added a new dependency, but we don't have them yet. This ID didn't download them just yet, or more particularly the project build tool that we have seen here in the Spring Initializr. Remember that we had picked out Maven, we could have also picked Gradle. And if you were to use Gradle, then this time around you would have used something like this. And all that being said, if I go back to IntelliJ and click on the Sync Maven Changes button, what it is going to achieve for us is that the Maven, the project build tool, is going to download the necessary dependency related files and packages, which are basically Java classes that you can reuse, so that we don't have to deal with downloading jars ourselves, putting them manually into our project path, etc. And right away we are seeing a warning. I'm just going to quickly look at that. Okay, there is some sort of vulnerability, and although this is not going to be a good example, I'm going to skip that for now because this is a personal project, and I assume if it was something that important, that's something I shouldn't even be considering running in my local computer, measures would have taken by the Apache community. So I'm going to go ahead to URL service. And this time around, if I type in random string utils, the IDE is going to be proposing a class that is under the package Apache Commons lang, the dependency we just downloaded. And if I go inside this class, what we can see is that there are lots of different methods that we can reuse without having to implement them. So I'm going to look for the method or methods that are called random alphanumeric. And okay, we have two of them actually. So we are going to have to inspect them. So what I'm going to do is that I'm going to copy this, go into the Spring random string utils class and look for these. One of them is just going to be taking a parameter called count. I suppose this is going to be used for fixed length values. And the other method is going to be taking two parameters, namely minimum length and maximum length. And I kindly assume that this is for flexibility in terms of length. So for this particular project, I would like a specific length that I specify in advance, which is going to be 8. And you can do the exact math, but as a spoiler alert, this is going to be result in billions of different unique codes, or more particularly character combinations that we are going to be able to use as unique code. And if I go back to the coding, this random alphanumeric method is going to be returning us a string object. So I am going to assign that to our shortcode variable here. And if I rerun my application, what I expect to see is that now every time we try to shorten a URL, instead of seeing to do in our shortcode, we are going to be seeing random alphanumerical values with the fixed length of 8. So I'm going to go back to the Postman and rerun this. And yes, this time around we get something else again. And if we go back to our database, all of these are persistent like this. Now the engineering design trade-off that you are going to have to make in this case is that, and the question that you are going to need to be able to answer that is going to be core engineering trade-off or of this project is going to be the question, how are we going to be able to enforce uniqueness for these shortcodes? Because if we come back here, we are not passing in any sort of prior information to this method. We don't say, okay, this and this we have already used. So this is just going to give us certain random strings. And although it is very unlikely that there are going to be overlaps or, more technically speaking, collision, we need to take a measure against that. That is going to be the responsibility of us as software engineers. Now, obviously, you can add unique constraint violation in your database level, which is going to be eventually useful. You cannot solely depend on your database because, let's say, I go ahead and change my database table specifications. I'm going to write a alter table query for this particular table, and I'm going to add uniqueness constraint to the field shortcode. I hope the syntax is right. Okay, I suppose I was supposed to be using parentheses for the shortcode, and I'm going to try again. Okay, this is not going to let me because we already have non-uniqueness in our database. So what I'm going to do is that to go ahead to application properties, and I'm going to make Spring Boot create this table from scratch. And if I jump over to my terminal and then re-execute the select query again, now we have an empty set so that we have a fresh table to work with. I'm going to add this unique index, and from now on, I'm not going to be able to insert duplicate shortcodes. And to make our Java code equally self-documenting, I'm going to go ahead to the URL entity, and as you can see here in this column functional interface, or this column annotation that we are using, there is a default unique property, and that default is false. So I'm going to make this unique true as well, so that the developers that are going to be working on this project also know that this URL is supposed to be unique, and actually not this URL, but this one. And I'm going to make some changes here, and I'm going to make sure that I made the correct one unique. Okay, add unique shortcode. There we are fine. And now if I for a moment replace the generation logic, and if I come back to our initial implementation with the to-do, and rerun my application, what is going to happen is that when I try to send a request for twitter.com, this is going to be persisted successfully. But when I change this, and I don't even have to change this time around, we are going to be encountering an internal server error because we were not able to gracefully handle the exception. Yes, we were not expecting a collision and overlap of shortcodes. And imagine this is not to do, but rather random string utils random alphanumeric method call. Very unlikely doesn't necessarily mean that impossible. And for the cases that are actually possible, you as an engineer are supposed to be able to handling those gracefully. So I think that goes on to show that why we can't just let this database enforce that unique constraint, because it is going to make sure that non-unique shortcodes are not going to be available in our database table. As you can see here, the last one we have here, the facebook.com, is not available on our database table. So the database application succeeded in its job and it's in its responsibility, but our backend application actually failed because it was supposed to return a short code for a single URL that can be reused later on, but we failed to do that. And that leaves with us two other alternatives that we can use. I'm going to go back to the IntelliJ. Now, the very least you can do here is that you can check if the shortcode exists in the database. And if it exists, you retry to generate the random string again. And if someone is unlucky enough to encounter with two collisions in a row, then it's their fault, you might say. Or you can go slightly more sophisticated than that, and you can implement the for logic with, let's say, 10 iterations. And if you have 10 iterations in a row, it is going to be literally, or not literally, but effectively impossible to collide 10 times in a row. So let me actually show you that. You can go ahead to your repository in which you can query your URL table. And by using the beautiful capabilities of this JPA repository and Spring Framework in general, what you can type in here that I would like to have a method that is going to be returning true or false. And that value is going to be representing if a shortcode exists, or more particularly a row with this particular shortcode exists in our table. And all you have to do is that you have to know and use this exists by keyword. And right after that, you're going to be using the exact keyword that you have here as a field. And last but not least, obviously, you're going to have to pass that in as a parameter so that the Spring framework, or more particularly Spring Data JPA, knows which shortcode to look for. And by that, what you can do here in this URL service is that, remember that we have the URL repository already available here. The very least you can do is that you may look for, okay, does this shortcode actually exist? And you can actually call this right away with the shortcode that you just created on the line 25. And if that is the case, you can actually reassign that variable with a new randomly created string. Or again, you can create a slightly more sophisticated version with a for an iteration or a while iteration, let's say. And here we come to one of the major design choices, one of the engineering trade-offs that we are going to have to do and decide right now. And that is, in this case, if I do this, my code is extremely easy to reason about. It is extremely too easy to implement, as well as maintain and read on later, even for junior developers, if that makes more sense. But what you have to realize here is that you're actually making a concession here. And that concession is that, or in a more simple word, the disadvantage is that now you are making 2 trips to your database every single time you would like to create a new short URL. Because when we had the exact same method like this, in this case, you were just creating the shortcode, creating an entity, and you were just going to the repository and try to save it. And if it fails, it fails. But the communication, the number of round trips that you had done, that you were conducting every single time for a single short URL creation was 1. But in this case, if I uncomment this, every single time you would like to create a shortcode, you actually go to the database twice. Your application goes to the database twice. First, it goes to check if the shortcode exists, and then it goes to actually process that data to the database. And you might be thinking, okay, if I don't go to the database, how might I know if a shortcode exists? And the answer to that question is quite sophisticated, in my opinion. You don't know if it exists. You just go there, and now you might be thinking, okay, that was we just did. You didn't like it. You said we didn't gracefully handle that, and that is right. The difference is that the way I propose we move forward is that we actually don't check the database beforehand, but whenever a collision happens, whenever a overlapping happens, we would like to handle that gracefully and not make the user pay for it, if that makes sense. And you might be asking, okay, how is this going to happen? And again, this is, I think, a very sophisticated way of going about this. If I scroll up a bit, remember that we had an exception when we tried to use the exact same shortcode twice, or more than once to be more technically precise. If you look at the Spring Boot logs, we have seen that this Java method, or more particularly this save line, it actually has thrown a SQL integrity constraint violation exception with a certain message that, okay, there were there were already some sort of shortcode in the database, but it doesn't really matter in our case. What we can do here, instead of making 2 round trips for every single operation, we can actually try that. And if it fails, we can try to handle that more gracefully. For example, what I can do here is that I can take all of this into a try catch block. And what this is going to enable me is that I can actually try to catch the SQL integrity constraint violation exception. And if that is the case, I'm going to rerun the exact same logic here again. And you should better try to refactor some of this code so that you have a more readable, more easy to maintain code, which you in advance reduce some complexity and reuse the reusable parts. But I'm just going to for now leave it as it is so that you can easily compare and contrast what is happening. Now the difference is that in the catch block, we don't do the validation URL again, because if we catch a SQL something exception, basically a constraint violation exception, that means that we actually got here. So this URL in the request DTO must be valid, so we can actually use that immediately. Or if you would like to be more precise, what you can do is you can take this variable initialization out of the try catch block so that you can reuse that in both try block and the catch block. Now what this is going to do is that instead of you having to do 2 round trips for every single request, you are going to have to do 2 round trips for only the ones that result in collisions in the first try. And I would like to run this application now, but I see an error here. Exception, SQL integrity constraint violation exception is never thrown in the corresponding try block. I doubt that. So I'm going to try to rerun this to see if this is an IntelliJ issue rather than a compiler issue, but it seems like this is actually a compilation issue. So I'm going to try one more thing, data integrity violation exception. Okay, that I knew because I have experience with this, but I think a fair question would be, as someone who have never encountered this before, how could it be explained that, okay, I see here SQL integrity constraint violation exception here, but I cannot really catch it? I honestly have no clue how to answer this. This is something that makes programming difficult as a whole, because sometimes you at least I cannot sometimes explain things, even if they are seemingly extremely simple. In this case, this is not. I have seen much simpler things that couldn't be explained by various people, including myself. And you might be asking, okay, what kind of value is this piece of information is supposed to be adding to the viewer, to you? And the answer is that sometimes you just have to accept it as it is. I hate to tell you this. I hate the fact that this might result in you thinking less of me, but this is actually reality. This is at least the reality that I perceive. So I feel obliged to share that with you so that this channel remains extremely honest and transparent, if that makes sense. That being said, we are going to go back to the project and run this application again. Now I'm going to check my properties because I don't want to recreate the data and the tables and everything every single time. And I'm going to go back to the terminal first and clean everything up. And then I'm going to execute the query. Okay, we have an empty set now. But of course, in order to be able to have a collision without having to try this a million or a billion times, we are again be using a hard-coded shortcode. And I'm going to rerun this one last time. And actually, I am going to get this running in the debug mode so that we can see line by line what happens. And I'm going to set a breakpoint to the start of this method, actually this one, but it doesn't really matter. And now, again, our table is empty right now, so we expect this shortcode to be persisted. Now, if I go to the postman and send a request again, now we are going to inspect what happens line by line. First of all, we are calling the isValid method, and which still returns the true as the default value. So we are going to skip the exception throwing part. Here we are going to be creating the entity. And now, as you can see here, and I'm sorry in advance if this is too small for you, but I have no idea how to make this bigger. Now we have a URL entity with the main URL facebook.com and shortcode to do. And if I try to save this now, this is just going to work fine. And it is going to be returning a response for us. And we are going to finally land in the URL controller. And I'm going to skip the rest by clicking on resume program. So if I come to the postman, we see the shortcode. And now if I come back to the terminal, as expected, we have facebook.com with the shortcode to do. Now, the juicy part is that if I try this with another URL this time around, if I click on send and try to go line by line again, okay, so far the exact same things happen. Now, again, without having to go to the database, we created our URL entity. We still have no ID. We set the main URL as twitter.com this time around, and the shortcode is to do. But the difference is that when I go one line further, which is the step over button here in this IntelliJ debugger, instead of line 34, in which this succeeded and we started building the response DTO, now this redirected us to the line 38, in which we are going to be handling the data integrity violation exception. And now we are going to try one more time. Imagine this happened because of a random collision. And now we are going to be trying to generate a random string again. And this time around, this is going to be this 7JJ something something. And then if I go ahead and try to save this now this is going to work just fine because it didn't collide with any other rows in our table. And now if I click on this resume program button, which is technically speaking is going to take us to the next breakpoint, but we don't have one. So this is going to execute everything. And if I come back to the postman, now we see that shortcode here. And if I go to my terminal and re-execute the exact same select query, now we see that main URL with a different shortcode. Now what we engineered here is that instead of 2 round trips between our Spring Boot application and the database application, for every single shortened URL request, we made sure that the number of round trip is only 1 for the successful operations, for the happy path. But in the case that a collision happens, then we make the number of round trip 2. And by that, we have achieved both performance because we effectively reduced the number of round trip by, let's say, 50%. And just for the sake of performance, we didn't have to make the user miserable or make the user experience miserable, if that makes sense. And now what we have to re-implement in this URL service now, and I'm going to close this debugger down. As you can remember, we didn't implement this isValid method. This is just going to be returning true every single time, which we don't want, because assume that I was about to type my first name and last name or Spring Boot diaries here, which is definitely not a URL, so we don't want to waste our resources, our computational power, and our storage space with something that is definitely not a URL. But in this case, if I click on send and I'm going to remove this breakpoint and resume my program, what happens is that if I re-execute the same exact query, now we have a Spring Boot diaries text that is, again, not a main URL. That is not a URL at all. So we shouldn't have this here in the first place. So what we are going to have to do is that, and I'm going to close this down again because my application was running in debug mode. And I'm going to go ahead to URL utils. A naive approach might be something like, okay, what if we look for the start of the string? Let's say we are going to be returning URL starts with HTTP. And this is going to handle easy cases such as this one. This text Spring Boot diaries does not start with the characters H, T, T, and P. So we are going to be able to eliminate that, but this is not enough. And here I'm going to propose that we adopt a test-driven approach, which is something you're going to see in a lot of job descriptions, TDD. And what it means is that you first write your tests and make them fail, and then you fix those tests instead of vice versa. You don't write code first and then test it, or more particularly, write tests for it. And there are use cases for both. Nothing is superior to the other, but for this case, I think a test-driven approach makes perfect sense, and it is a good opportunity to show you that as well. So I'm going to go ahead and find my test package, and under the shortener package, I am going to create a new package called util, because again, that is the name of this package in which we have this URL utils class. So I'm going to call this URL utils test. And again, I'm going to open them side by side so that we can, again, cheat a little bit. And in this class, I'm going to write a simple Java method, and we are going to actually remove this one, but I would like to make this as approachable as possible. And I'm going to call this method test underscore is valid. And before testing anything, I would like to show you a bit of JUnit basics. What you have to do here is that, let's say, for example, I would like to call that the value false is actually false, which doesn't make any sense, I know, but this is just to show you how it's done. In order to be able to run this test case, you have to do two things basically. You have to first remove this public modifier, and you have to add a test annotation, which comes from the JUnit package. And right away, you are going to see some green rectangles around here with which you can run this test method, or you can run this class in which there are going to be several test methods and it is going to run all of them. But in this case, this is not going to matter. And if I click on run test is valid, we are going to be seeing some greens on the bottom part of my screen, which is nice. But let's say I try to say, okay, assert false, that the value true is actually false, and the ID is going to warn us about that. This is just going to fail. What are you doing? But we are going to ignore that for now. And if I run this now again, this time around, we are going to be seeing that the assertion failed because it was, okay, whoops, because it was expecting a false value because we used the keyword, we used the method in the assertions class, assert false, but the actual value we provided was true. And just like that, you can actually do the exact same thing with this URL utils class and this is valid method. And just like, for example, in this URL controller, we needed a class variable URL service. In this URL utils test, I'm going to need a private class variable with the type URL utils, and I'm going to name this variable URL utils. Now I'm going to take this here so that we can have this full size. And actually, I'm going to open up the URL utils again. Whoops. What you can do here, instead of asserting that this value true is false, which does not make any sense at all, what you can do here is that you can call the URL utils is valid method. And let's say I'm going to call this with a Spring Boot diaries parameter. And I suppose this is not going to run because we don't have a URL utils instance. As you can see here, this is going to be complaining because this .url utils, aka our class variable, is null. And there are a couple of ways to overcome this. The easiest one, of course, is to create a new URL utils yourself, now that this class does not have any sort of dependency. And if I try to run that now this time around, the test is going to succeed. But this is honestly not that springy, if that makes sense. So what you can do here is that you can annotate this class with a Spring Boot test, and you actually have various other methods as well. Method in a sense that way of doing things, not in the context of Java methods. And you can actually annotate this with a auto-wired annotation. And if I run this now, without me having to recreate this instance every single time, Spring Boot actually is going to be handling that for me. But the disadvantage of that is Spring is going to have to load the entire context, and this is not going to be as fast. So for the reason this is a video tutorial that speed is important, I'm going to do it the initial implementation. But again, I would, in a real project, I would suggest you to not use this, because if you use this and someday you would like to add another dependency to this URL utils class, then you're going to have to come back and fix that test class as well, and this is not going to be pretty. So in a sense, is this fine? Yes. Would I suggest it? No. And that being said, I'm going to use it nevertheless because the speed matters the most for this video tutorial. If we finally come back to the test-driven development, what we can do here, we can actually set up various test cases. So I'm going to just duplicate this now, and I'm going to make this start with HTTP, and then I'm going to have a proper URL, http.facebook.com. And this one is with HTTPS, and I'm going to also have one with HTTP, facebook.com. And finally, I'm going to type in HTTP, and then I'm going to leave it as it is. And it is also always useful to add null checks in your test cases. Now, before running this and seeing that this fails, I'm going to fix my assertions. So first of all, I want this method to return false when this parameter is given. So this is going to stay assert false. And this is also going to be assert false as well. But for these two, I would like to assert true because these two are actually valid URLs. And for the last two, I again want to keep them as they are. And if I run this now, if I run this test, this is not going to succeed because our logic here that we have on the right side does not meet the requirements of these particular test cases. And this is what test-driven development is about. Instead of we implementing the method first and then writing the test cases, we first write the test code and then we actually see it fail. Now we are going to fix it. And the easiest way to validate URLs that I know is that you can use this URI class that comes from the basic Java package. And if I'm not mistaken, I was going to say this URI class has either a method name of or create, and right away we see this create method. Now, if we go inside this, what we see is that this method is going to be taking a parameter of type string that is to be parsed into a URI, and this is going to be returning a new URI object. And if there is an issue with the URI syntax, this is going to be throwing an exception, but we don't want any exceptions. We just want simple validations, and we would like to have this method return true or false. So what we can do here is that we can pass in this URL variable into this create method of this URI class, but instead of throwing an exception when something is wrong, and I'm going to try this one, and actually the compiler doesn't even let me do that because URI create method actually returns a URI object, not a Boolean value. So I'm going to have to do what I was intending to do in the first place. So I'm going to wrap this into a try catch block like this. And I'm not even going to be using the return value of this create method, and the IDE is going to be pissed about it, but that is intentional because I'm going to try creating this URI object, and if there is no issue, then I'm going to be returning true because this URL is going to be valid. But if I catch any sort of exception, and you might want to be more specific with this exception, but I honestly don't see any other way that we get an exception other than this URL parameter being invalid, I am going to be returning false instead of throwing any sort of exception. Now, if I come back here and rerun my test cases, now this time around, this is going to work just fine. And I'm honestly not sure if this is enough by itself, because if I remember in a project, I had also used this toURL method, which is, again, it comes from the URI class that is going to throw another form of malformed URL exception. And I'm not sure if there are any cases that it covers that these first parts do not cover. So I'm going to try this again as well. And if both of them works, I'm going to use the next one because this seems like a more comprehensive approach. But of course, in a real life project, what you would do is that now that this line of code is going to be running for every single request, you would like to make sure that it is as efficient as possible. So you would like to avoid redundant calls. And now if I come back to the URL service, what we are going to see is that this isValid method is actually be doing something that is purposeful. So if I run my application now, and now that I have tried to run my test cases a couple of times, the last thing that I ran was these test cases, particularly this test method. So if I click on run now, by default, the IDE is going to run the test cases again. But I would like to run the main application class, the main method in it, and I don't want to come here every single time. So what I'm going to do is that I'm going to pick out shortener application and then click on run to get my Spring Boot application up and running. And now this time around, if I go to the Postman and try to do the exact same thing, now this time around, we are going to be getting an internal server error. And if I come back to the IntelliJ, we are going to see that we see a runtime exception, URL is invalid. And this is not ideal from a client perspective, but this is a good start. And if I'm not missing anything, with that, we actually have implemented our first shortened method and API as a whole with no serious issues or serious to-do items in it. And that is going to bring us to the next part where we actually use these shortcodes to provide the clients of our applications with redirects. And before doing that, I'm just going to replace this to-do item, to-do string, with random string utils random alphanumeric method call. And I'm going to stop my application now. And I'm going to clean all of this and have a fresh start. I'm again going to go back to the URL controller we have, and now we are going to have the second API that we are going to need this project. Now here we are going to again re-adopt the API first design principle. And to be perfectly honest with you, it would probably make more sense to do that for the both of them without writing any sort of service layer logic or persistence layer logic. But again, to be as transparent as possible, I got actually extremely excited for the content of this service layer that we have built together, so I got carried away with it. So without further ado, I'm just going to create a new Java class again, sorry, Java method. And then this method is going to be returning something we call a response entity. And if you have no idea what it is, I'm going to try to recap that. But if you have a full explanation, I have a video on that. A response entity is basically something, basically a class that Spring Framework provides us with so that you can have more fine-grained control over your HTTP response. Because although we are thinking in terms of Java objects, in terms of what we are returning from these APIs are actually not about returning Java objects. They are technology agnostic in a sense. So APIs are actually about producing HTTP responses. And even if you specify it or not, for example, in the case of shorten URL API that we just implemented, we didn't have a fine-grained control over our HTTP response, but nevertheless, Spring Framework handles them for us without we having to explicitly state our intentions. It is going to be returning 200 success response. It is going to be returning certain response headers in that response. But in the case of redirecting our clients of this particular application, we are going to need that because in the HTTP world, redirection functionality has a different family of HTTP status codes. If I type in, okay, HTTP status, and this is not going to show up, I'm going to try it this way. And if I go inside this, if I manage to go inside this, what you are going to see is that we have certain HTTP status code families. 100s are for informational values and 200s are for successful responses. And as you can see here, we actually have a series in them that I didn't even see here. And if I go here, this is going to make it much easier to explain this. We have various families of HTTP status codes, and the 300s are responsible for redirections. And if I go to the top of this enum again, we are going to be seeing certain HTTP statuses such as moved permanently, found, and we have temporary redirect. And these have very minor differences between them. So as a backend developer, I'm again going to be honest, and I'm not going to be able to explain the details and the minor differences between them. But for all I know, as a backend developer, you are going to be more than fine, especially if you're a junior, if you know that the 300s belong to the redirection group. And to be even more perfectly transparent with you, you might not even have to know that too in the first place if you are beginning out with your career from scratch. So of course, it doesn't hurt to have a bit of an additional knowledge. So you might as well try to remember that the 300 group in the HTTP status codes represent redirection. And if we come back to the controller, what I was going to tell you is that in this case, we are not going to be able to return a simple string. Like, for example, we have a basic Java method called get redirection URL, in which we are going to be taking a parameter shortcode. And this is actually going to come from the path we are going to be specifying. And this is going to be a path variable because this is going to vary. And so this is going to be a variable in our path, if that makes sense. We are going to have a shortcode, and I'm going to have to annotate this parameter with a path variable annotation so that the Spring knows that this particular field should be inferred by this certain variable in our path. And then before implementing anything, let's say I would like to return the client of this API to https://google.com. And if I run this now, if I make this line complete and run this application, and now this time around, instead of using Postman, I'm going to use Google Chrome. And imagine I go localhost something, and dashboard would work just fine because this is going to take everything. And actually, in order to be able to make sure that this is visible, what I'm going to do is that not rerun that, but actually stop that. And I'm going to add a postfix of shortcode. And if I run my application now, and again move over to Google Chrome, if I call this API, this is going to be returning https google.com/dashboard. But imagine we would like to redirect the user to this particular URL. This is not how URL shorteners work. We would like the clients, we would like the users to directly land into that web page or web URL that we are going to be holding in our database. So you need fine-grained control over your HTTP responses, and you are going to have to specify certain HTTP status code, which is going to belong to the 300s family. And then you are also going to have to return a location header, a header called location, so that the browser knows where to redirect the user. So how you do that is how you implement is that instead of a string, you return a response entity. And this response entity is not going to contain any response body. So the return type of this response entity is going to be void. And if you go inside this, this is just a simple Java class, which represents the keyword void for certain use cases, for example, this one. And what you're going to have to do is that instead of this, you are going to be returning a response entity with the status. And here, as you can see, you are going to have to either specify an HTTP status code or an integer. And we can do that by typing in HTTP status. And I'm going to look for what the 301 was. Okay, this is moved permanently. And again, there are very minor differences between them. So you are going to be just fine using any of these two at least. So I'm going to use moved permanently. And then I'm going to get the integer value of that HTTP status. And you might be thinking, okay, if we are looking for the name of this enum by looking at its value, why don't we just type in 301? And the answer is that you would like to be as descriptive as possible with your code, because even though you know this now, A, one case would be that you might forget this piece of information 6 months from now. B, some other person who are not extremely familiar with the HTTP status codes may see this code, a junior, for example, or an intern, and then get confused. So you would like to make your code as visible, as descriptive as possible. And if we come back to implementing this API, you are also going to have to specify a location, and that is going to be our long form URL that we have taken, that we will have taken in this shorten URL request DTO, or in this case, this one, but this is not going to compile because as you can see here, this location method of this headers builder interface is expecting a URI parameter. And as you can remember from our URL utils, we can actually create that by using the creation method. You're using the builder method of the URI called create method. So what I can do here is that I can cut this out, and instead of trying to pass it in as a string, I can type in URI.create, and now this create method is going to be taking a string that is to be parsed into a URI, and I am able to pass the string in and realize that our ID is telling us that this is not going to be returning a response entity. This is going to be returning a builder on which you can call methods like location again, or content type, or set certain headers. What you're going to have to do is that you're going to have to call the build method that is going to be returning us a response entity. And that is actually the exact same pattern that we actually have used here for this shortcode generation. The only difference is that the bodybuilder implementation of the response entity class is much more sophisticated than this one. So if I go back to the URL controller, what this is going to do is that this is now going to return the browser, return the client, the HTTP status 301, as well as it is going to be providing the location that it should look for, or more precisely, the URL that the browser should redirect the user to. So if I run this now again, and if everything is fine, I'm going to go back to the Google Chrome. And now if I try to call this localhost 88 dashboard, see what happens. Now I landed in a my account google.com/dashboard something. And that happened because Google itself has actually implemented a redirection itself as well. They anticipated that some people might try to go to google.com/dashboard, but they don't have that. They actually have that under the my account google.com. So they decided to take measure against it, and they decided to implement a redirection themselves. So in this particular case, and I didn't make this on purpose, we were actually redirected twice. So of course, what we would like to do is that we don't want to go to the Google.com dashboard every single time, or anything related to the google.com. What we would like to do is that, as you can see here in our database, we have the URLs that we have assigned certain shortcodes for. So we would like to get the main URLs by using the shortcodes and then redirect the users based on those database rows. So I'm going to go back to the IntelliJ, and instead of URI create, I'm going to assume that, and assume for a split second, that we have a URL service method that is going to be returning us a get redirection URI with the parameter shortcode. And I'm also going to rename this Java method that we are going to have, that is going to serve us as a REST API. And now right away, the ID is telling us that there is no such thing as in URI service. And that is actually what I wanted in the first place. Now it is proposing that should I create that method? And I'm going to say yes. Now remember that in the URI create method, if I can find this, okay, we need a string. We need a string to be parsed into a URI. So first things first, we are going to be need to fetching this URL, or more particularly this database row, or more particularly this database table row. And then we are going to be creating that URI instance using this main URL. So what we have to do is that we need a way to retrieve a URL entity. And as you can remember, we had certain URL entities that were mapped to certain roles in our database, or more particularly this URL table. And we had actually implemented a URL repository that we can use for certain out of the box functionalities. And now that this is no longer used, I'm actually change this and I'm going to make this find by shortcode. And this is not going to be returning a Boolean value anymore. This is going to be returning us a URL entity. And we can actually make this more performant by not retrieving the whole URL entity, but just the main URL. But I think that would be an overkill for a tutorial project. But keep that in mind for a technical interview if you would like to add this to your portfolio. So I'm going to go back to the URL service. So I have no idea what happened here. So I undid the operation that somehow happened. Okay, so this is going to be returning us a URL entity. And then if I come back to the URL service, now what we are going to do is that, and again, remember that in this class, we already have a class variable called URL repository so that we don't have to reinstantiate an instance every single time. What we can do here is, first of all, we can get the URL entity using the repository method we just created. We can say find by shortcode and we can pass the shortcode in. And now there are two ways to go about null checks. You can actually call objects is null URL entity, and then you can do some checks. But what would be more sophisticated than this is that if you go to your repository, you can actually make the return type of this particular method find by shortcode with the parameter string shortcode. You can actually make this optional of URL entity, and the JPA repository is going to handle the rest for you. And here in this URL service, you can have a much more refined approach. So what you can do here is that you can use some of the optional class capabilities. And here, instead of a URL entity, you can try to get a URL that is going to be parsed. And I will call this URL to be parsed. And I'm going to use the map method of this optional class. As you can see here, this method comes from the optional class itself. And I would like to use URL entities get main URL method if the optional entity actually exists. And if not, I am going to be returning a slash because I would like to keep the customer and I would like to redirect them back to our web page. And then we are going to be returning URI create with the URL to be parsed. And obviously I'm going to have to end this line with a semicolon. And in our controller layer, what I'm going to do is that, okay, I already have done this. So now I'm going to rerun this again. And I'm going to take a shortcode from our database, which is going to be redirecting, at least it is supposed to be redirecting us to the Twitter. And when I go ahead and type in localhost 8080 with this particular code, I'm going to hopefully end up in x.com as it is now called. And by that, we actually have completed our project. So now we have the capability of shortening a URL, saving it to the database, and then when someone calls the GET API that we just implemented, instead of sending them the URL as a string, we are sending the browser the command to redirect the user to that particular URL, and that is what URL shorteners are for. And obviously, there are lots of improvement points in this project, but for starters, I think this is a very good start. I think if you understand when to use post mapping and when to use get mapping, or when to use post versus put mapping, or if you understand certain annotations in this class and you understand the certain generation type strategies and their trade-offs, as well as the one we explained when implementing a retry mechanism, if you understand that engineering trade-off, I think you are going to be golden if you're a junior. And if you have a basic understanding of this controller server repository, aka the 3-layered architecture in Spring Boot, and if you understand the separation of concerns as a whole and the idea behind that, and finally, if you're able to write basic code to test your application's logic, I think that is all you need to know to land a junior position. And in fact, I would even probably tell you that this would be enough to land an intermediate position if you ask me, because I have met lots of people who have years of experience in Spring Boot who hadn't really understood and internalized these topics. And that actually includes me, myself, 2 or 3 years ago as well. So if you really understand what happened here, and if you feel confident rebuilding this, which I would definitely suggest you, just close down the video and try to re-implement the whole thing and grind through, sit through the project. This is not going to be easy. I have 5 years of experience with Spring Boot, and this took me a whole evening. I mean, okay, I tried to explain things, but still, this took me a lot of hours. So if you're a beginner, if you're just starting out with Spring Boot, no matter how much Java experience you have, you are going to encounter some difficult to reason about problems, just like we have seen this SQL integrity violation exception versus data integrity violation exception, so on and so forth. Or you are going to have problems, let's say, connecting to a database, and you have to sit through it. And I promise, if you sit through that, and if you get yourself building real projects, real life-like projects, it is going to be a matter of time until you really understand and deeply internalize the basics of Spring Boot. And that is actually it for the whole video. I really, really, really hope that you found this video and this tutorial helpful. And again, I definitely suggest you to try this as well on your own. And please make sure to like and subscribe if you enjoyed this video and would like to see more of it. It definitely helps me keep being motivated. And I hope to see you in the next project tutorial.